All right, everyone. So, in the last lesson, we discussed a few things related to the elemental notation. So, as you can see over here, you've got a few things which we need to recall. So for this elemental notation that you see over here, this is for sodium. You've got your symbol, you've got these two numbers, and then this small number is your atomic number, whereas this big number is your atomic mass. So the atomic mass, let's recall, tells us the sum of neutrons and protons. So this is basically n plus p, so neutrons plus protons, right? Whereas the small number, atomic number, tells us the total quantity of electrons or protons. So similarly, by looking at this elemental notation, I can find out the subatomic particles of sodium. So a sodium would typically have 11 electrons, 11 protons. By seeing this small number, it lets me know the total quantity of electrons and the total quantity of protons, whereas this big number is having the quantity of neutrons, but this quantity is a bit hidden. The reason why this is hidden is because you need to subtract this 11 by 23. Now, why do I want to subtract this? It's all because of the fact so that I can get the number of neutrons only, because this sum is having neutrons plus protons. So what I'll do is, I know the quantity of protons. What I'll do is I will subtract this quantity of proton with this sum. So this will eventually subtract all of the protons which are in the quantity, and this is how you'll just get the neutrons. So the neutrons are going to be 12, sorry, it's going to be 12. So this is how, whenever you subtract these two numbers, you get the neutrons. Right, now let's move on towards a little bit more, uh, like uh, let's recap it a little bit more with the atomic structure. Now, as we know that we are solving everything for the subatomic particles, right? Now, our second step is the atomic structure. So, we all know, as we have discussed in our classes before, that atom is having tiny subatomic particles which are classified in an atom just like this. As you can see, the neutrons and protons are in the nucleus, whereas the orbits contain the electrons. So this is how, when you are able to distinguish, or you are able to calculate the number of neutrons, protons, and electrons by looking at this elemental notation, the second question arises that how is the atomic structure going to be for this particular sodium, right? For this sodium. So the answer to that is pretty straightforward and is pretty clear. So you can see over here, you will first draw this nucleus, and in this nucleus you will declare the number of neutrons and the number of protons. Now for the orbits, the first orbit is a duplet. So you can see over here, I've tried to organize the electrons. So we have got 11 electrons. So the first orbit accommodates only two maximum number of electrons, whereas the second orbit can accommodate 8 electrons, and so on. The other orbits can accommodate 8 electrons because they have the same capacity of accommodating the electrons, right? So the first orbit that we are talking about is duplet, which can only accommodate 2 electrons. So you can see over here, I've accommodated 2 electrons in the first shell, whereas if I'm talking about my second shell, you've got these 8 electrons. Now the leftover electrons are obviously going to be catered and are obviously going to get accommodated in the in another shell that I've made. So the leftover electron is accommodated in the third shell. So this is how our atomic structure for sodium is completed, right? Now I will walk through a little bit of an activity where the we will solve the subatomic particles. We will try to make some atomic structures, and then after that, if we have some time, we will make sure that we distinguish the group and period by looking at the atomic structure. So now, here goes our first example. So I've got my elemental notation for hydrogen. So you can see clearly these numbers, they do not they're not different, so they are alike. So 1 1 and 1 minus 1 is going to be 0. So this case is a bit spatial, so that is why while deducting both the numbers, there are basically no neutrons, right? Now, for making the atomic structure for hydrogen, always remember that in the nucleus there will be no neutrons. So the neutrons are going to be 0, the protons are going to be 1, and the electrons, as for the electrons are going to be, you're just going to make one electron and that's it. So yes, you've got your atomic structure for hydrogen. So by looking at this elemental notation, I was able to figure out, I was able to calculate the subatomic particles, and now the atomic structure is developed as well. Now, in a few minutes, I will tell you a technique by looking at this atomic structure. How can you define the group and the period of the elemental notation, right? Now, for hydrogen, since hydrogen is a bit similar to group 1, it is similar to group 4 and 7. So, this elemental notation that you see over here is a special case. So it has an anomalous position in the periodic table. So it is similar to group 1, it is similar to group 4 and group 7. So this is a special case. Apart from that, everything will get aligned in the periodic table as when we'll do this activity in a few minutes. So now, for the number of neutrons, protons, and electrons for helium, here I go with the calculations. So looking at the small number, I've got 2 over here. So it represents the total quantity of protons and the total quantity of electrons. So I've got my electrons and protons as 2 declared over here. So by subtracting the big number by the small number, I will get 2 over here, which is going to be the quantity for my neutrons. Now, the neutrons are 2 in the nucleus, the protons are 2 in the nucleus. Now, for the first shell, I'm just going to put 2 electrons now. So 1 and 2. So here I go with my atomic structure for helium. Yes. So now in the periodic table, if you see in the periodic table, helium is somewhere located, right? Now, by looking at this atomic structure, now what do I see? I can see the number of shells. So I've got one, so number of shells. So I'll make this really simple for you. So the number of shells will describe you about the period. It will tell you about the period. So period is the horizontal raw, whereas the number of valence electrons, so valence electrons are the electrons which are in the last shell. So in this case, a valence shell is this one. The first shell is technically the last shell because this is the only shell that we have in this atomic structure, right? So obviously in this first and last shell we have just got these 2 electrons, so they will be called as valence electrons. So the number of valence electrons will let you know the specific group. So now, by looking at the periodic table, you will see that helium is having a period 1 because it is only having this one shell, whereas its group is going to be 2. So the group is going to be 2, right? So the group is going to be 2. Now, you will see that in the periodic table, this hydrogen and helium, they are a bit different from the law, from the technique which I'm trying to explain you, because they are special cases, right? But this thing will actually work out from the elements that you will see from now onwards, like lithium, beryllium, boron, and uh, from this third element to first 20 elements. Sorry, for the first 20 elements, like from this third element till your 20th element, you're going to see that this rule actually applies. All right. Now, let me raise a few things so that now I can make sure that I explain you what's going on. So for lithium, I'll very quickly solve this one. So for lithium, I've got my neutrons, protons, and electrons as 3, 3, 7 minus 3 will be 4. So I won't go into the details now because we know how to take out the subatomic particles. Now I'll quickly make the atomic structure. So this is going to be 4 neutrons and 3 protons. And now for basically the allocation of the electrons, we have got 3 electrons, right? Now, so 1 and 2, we've got 2 electrons in our duplet, and then the leftover electron will be accommodated in octet, which is our second shell. So we need to remember that the first shell is called as duplet, and the second shell is called as octet. And this is how they are basically shells, energy levels, orbits, shells, you can say them anything, right? Now, as for this rule now, so you can clearly see you've got two shells. So the period is going to be 2 because you have got two, the number of shells, you've got two number of shells, right? And the group is going to be 1 because in this valence shell, last shell, you've got this one valence electron. So this is how this rule is applicable. And by looking at the atomic structure, you can literally find out the place of this elemental notation in the periodic table. So this is what I wanted you to understand. And this is applicable for lithium, and it is applicable till first 20 elements, right? And you can clearly see that this is getting followed. Now, if I quickly go on with an example, with another example of beryllium, so very quickly what I'll do is I'll solve for beryllium, right? So we have got 4, we have got 9. Very quickly the subatomic particles will be this is 544 are the subatomic particles. So for the nucleus, we have got 5 neutrons, we have got 4 protons. This is our big nucleus. Then we have got our orbits. So very quickly, we've got our electrons. So 2 electrons getting accommodated in duplet, and the leftover 2 electrons will get accommodated in our octet. So this is how we are now accommodating all of our electrons. Now, if we see the number of shells, we have got 2 number of shells. So it will probably be in the second row. So beryllium is going to be in the second row. So the period is going to be 2 because the number of shells describes the period, the horizontal rows. And for the group, which is the vertical column, so for the group, last shell, valence shell, valence electrons. We have got 2 valence electrons. So the group is going to be the second group. So this is how you get to decide the location of beryllium by literally looking at the atomic structure. So you can follow these. I've got less time in this lesson, so I'll stop this right now. Uh, but then again, I'll make some new lessons where I get to solve a few more, and I hope this video helped you understanding the concepts of atomic structure, and the way how you can locate their basically their location in the periodic table. So thank you so much for watching this, and I'll see you in the next video. Thank you.